What's up everybody, welcome back to another video. Today we'll be learning about arc length. Now, arc length is basically what it says in its name, the length of an arc, or the distance of a specific arc or section of a circle. So, as you can see in this example I have right here, what we're going to be learning today is we're going to be learning how to solve for the length of this section right here, this arc. And to do that, we have to use a very simple but useful formula, which is S equals R times theta. So obviously first we want to define each variable and establish what it stands for to understand how to use the equation. So S itself stands for the arc length. S represents the arc length which we're solving for. So obviously our equation would be equal to S, which is the variable, or which is what we're actually solving for. And R represents the radius, and you all know what a radius of a circle is by this point, and it's very useful in determining the arc length. You need it. And finally, you also have theta, and theta represents the central angle. And this is basically the angle that's given to you in each problem. And both the radius and central angle would be given to you in order to solve for the arc length. So for example, if I was to set up the first problem, let's say I had the circle right here that looked just like that. And let's say I came up with the angle of 55 degrees. So that's the angle of the that's the measure of the central angle. And then let's also say that the radius is 4 feet. So this right here, this line which represents the radius, these two, they're both 4 feet. So if I give you that information, how would you solve for this part, for this sector, which we're looking for right now? Well, it's actually a little trickier than you think. You might not think that, we just substitute in the radius and measure angle given to us, but there's a little step that we have to do in between. So for the radius, we can actually just take the 4 feet. We can put that in for the radius, but we have to change theta a little bit. So hopefully you guys watched our video on converting radian and degree measures, but that's what we're going to have to do with this right here. We're going to have to convert this 55 degree measure to a radian measure, and hopefully you guys remember how to do that. All you have to do is just take the angle measure, which is in this case is 55 degrees, and multiply that by pi over 180. If you do that, you get 55 pi over 180, and that can be simplified to 11 pi over 36. So now that we have 11 pi over 36, all we want to do is actually solve for that. We want to solve for what it equals to. So all we get is a calculator. We do 11 pi over 36, and that equals approximately 0.96. So now that we have an actual number, we can substitute this 0.96 into our theta, and then we get the S equals the radius, which is 4, times 0.96, which is approximately the value of the angle we have in radians, and then we multiply the radius and theta, and then we get that the arc length is approximately 3.84 feet. So this is the first problem that we've done today, and it definitely may look a little complicated, but the easiest part of this is just remembering the equation. It's a very simple equation, and all you have to do is take the central angle given to you and convert that into radians, solve for the actual numeric value, and then substitute onto the equation with the radius, and then you can solve for your arc length. So hopefully you guys understood that, and with that, let's move on to example number 1, or practice problem number 1, shall I say. So now I'm going to give you guys the information, and I want you guys to try and figure it out on your own. So the angle I'm going to give to you, the central angle for this problem, is 100 degrees. And the radius length will be 6 feet. So on that note, please try to pause the video and figure it out if you can. Alright, so hopefully you guys paused the video and made an attempt at it, but I'm going to go over it real quick. So we're going to do basically exactly what we did last problem in our example problem, but obviously we're going to use the different values given to us. So we want to use the equation S equals r theta. Okay, good. We already have our r, which is 6, so we can keep that aside. And now what we want to do is convert this 100 degrees to a radian measure. So we just do 100 times pi over 180. And this one you can just do in your head because 100 times pi over 180 is 100 pi over 180, which can be simplified to 5 pi over 9. So now that we have the 5 pi over 9, we can actually convert that to, or we can solve for its numeric value. 5 pi over 9 is just approximately 1.75 or 1.745. So now that we have an approximate numeric value for our theta, we can do what we did again and then just substitute in to this equation. So then we have S equals 6 times 1.745, and then 6 times 1.745 approximately equals 10.472, which means that the arc length for this problem that we've been solving for is approximately 10.472 feet. Remember to use the proper units as well because the radius was given to us in feet. So hopefully you guys got that. Let's move on to practice problem number 2. So for this problem, I'm going to give you guys some more info. So now what I want you to do, or what the info I'm giving you, is 90 degrees for the angle, the central angle. And I'm going to tell you that the radius for this problem is 5 feet. So with that info, please try to solve the problem. Pause the video and just try it out. Okay, so hopefully once again you guys tried it on your own, you pause the video, but let me explain it to you guys. So we want to do the exact same thing once again. Use the equation, solve for the numeric value of the degree, and then substitute and then solve. So we have our equation right here. S is equal to r theta. The radius is 5, so we have to keep that in mind. And now we know that our theta is 90 degrees. But we can honestly solve for this in our mind, So you have 90 degrees. To convert that into radian measures, you just multiply that by pi over 180. Well, 90 times pi over 180 is 90 pi over 180. And that can obviously be simplified into pi over 2. Try to write it down if it's a little complicated, but hopefully you guys understand how to simplify that easier. But all we have to do now is actually solve pi over 2. And pi over 2 approximately equals 1.571. So now that we have the numeric value, we can substitute this into the equation along with the radius. And then we end up with S equals 5 times 1.571. And 5 times 1.571 is approximately S equals 7.854 feet. And remember to use the proper units. Now, whenever solving for this kind of thing, it usually varies on how many decimals you want to use, but I suggest using 3, rounding to 3 decimal points. So hopefully you guys got this one, and let's move on to our practice problem number 3, where we have this one. Again, this is going to be the same kind of thing. We're just going to be practicing. So in this one, I'm going to give you the angle of 205 degrees. And I'm going to tell you the radius length is 2 feet. So once again, please try to pause the video and try it on your own. Alright, hopefully you guys tried it. Let me just skim through this one quickly. Once again, it's the same thing that we've gone over in. Practice makes perfect, so hopefully you guys are getting the hang of it now. But all we want to do is take our equation, S equals r theta. The radius is 2, so you got to keep that in mind. And then we have 205 degrees, convert that to radians. So obviously this is a little trickier simplification. So I'm going to write this one out. 205 degrees times pi over theta, or pi over 180, equals 205 pi over 180. And now we actually just have to simplify. So that means 205 pi over 180 can actually be simplified to 41 pi over 36. And then if you actually solve for the numeric value of that, you should approximately get 3.578. So this one's a little tricky only because the radian measure we're trying to solve for is a little larger number and is a little harder to simplify. But now that we got the numeric value, once again, all we have to do is just substitute the values we have into our equation. And then we get S equals 2 times 3.578. And then that approximately equals 7.156 feet, which means for this problem, our arc length is approximately 7.156 feet. So now that we've done this, or the same type of problem, but with different values or different pieces of information, hopefully you guys are getting the hang of it and you understand how to use this equation properly. So as we move on to our last practice problem, this one is a different type, and let's read the practice problem first. If the arc length is 3 feet and the measure of the circle is 70 degrees, what is the length of the radius of the circle? So how is this one different? Well, let's see. In this case, we're actually giving the arc length at first. We're given the arc length and the measure of the angle. Usually we're given the radius and the angle, but in this case we're given the arc length. And they're asking us to solve for the length of the radius. So what does this mean? Well, it's basically just as simple as the last one. We use the equation in all of the last problems, and we're going to do the same thing now, but instead we're going to solve for the radius instead of solving for the arc length. So if you guys want, you can actually pause the video and try it on your own. It's not that difficult. Just try to substitute the values, solve for the correct measure that you'll use in your equation, and then solve for your radius. So pause the video if you want to try it out. I'm going to go over it right now. Okay, so once again, let's get our equation in here. So S equals R times theta. Okay, well, first what we can do is just solve for the actual measure of the angle, make it into a radian measure. So they give us the degree measure of 70 degrees, so all we have to do, convert that into a radian measure. So we get 70 degrees times pi over 180. And then you can just think about it in your head. That gives us 70 pi over 180. Cross out the zeros or simplify, divide each by 10, and then you get 7 pi over 18. So now that you have 7 pi over 18, you actually solve that, do 7 pi divided by 18, and you should approximately get 1.222. So now after you got 1.222, which is the value or the radian measure of your angle, all we have to do is once again substitute like we have been doing, and then we get 3 equals R times 1.222. And what we can do is divide both sides by 1.222 approximately, and that means that for this problem, our radius will approximately be 2.456 feet. So this last problem was a little different, but hopefully you guys understand it. It's always good to try different problems to actually understand the concept. But all arc length basically is using the equation properly and solving for the right pieces of information, then substituting, then solving. So hopefully today's lesson or today's video helped you guys out and you now understand arc length. If it really helped, please consider subbing to the channel and dropping a like. Thank you for watching.